Here is an excellent question which is about absolute of quadratic function. Now I would like you to take this as your test problem, right? Now test problem for me means that read the question, pause the video, solve it, and then look into my suggestion, right? That way you'll get the most benefit. Now let's go through the question first. Sketch the graph of function f of x equals to absolute value of x squared minus 1. So you need to get the skills of advanced functions now, right? Sketch the graph. And part A and B are, for what values of x is the function not differentiable? And B is, find f dash x at x equals 2, minus 2, 0, and 3. Correct? Now first thing first, that is to sketch the graph of function f of x equals to absolute value of x squared minus 1. Now to sketch these kinds of functions, what should we do? Absolute function is defined as everything should be positive, right? So negative things will become negative of negative to make it positive. So what we will do here is, we will first sketch x squared minus 1, right? So x squared is a parabola with origin at vertex. When you move it 1 unit down, it becomes x squared minus 1. So we have a parabola like this, and let's say this is my 1 unit down, and that is my function x squared minus 1, correct? So if it is x squared minus 1, this point has to be minus 1, right? Now if x is 0, this is minus 1, and these x-intercepts will be the values which will give it 0. So those are plus minus 1. So here we have minus 1 and here we have plus 1. So this is our sketch for the function. Correct? Now when we say absolute of this value, then it means that this part is fine. This part is fine because it's positive, right? So this part is fine. And this part is also okay. But this part has to be flipped. So this minus 1 will come to 1 and we'll have a function like this. So if you flip it like this, kind of, let me just connect it right now. So that function becomes the absolute function. Do you see that? Now straight away you notice one thing, and that is that there are corners here, correct? So we have a corner here and a corner there. So these are the corners, sharp corners. So these are the points where the function is not differentiable, right? So the points which they are asking for what values of x is the function not differentiable? So you now know the values of x. These are these 2 points, right? So not differentiable, we got one answer, not differentiable are the points which are x-intercepts in this case, minus 1, 0 and 1, 0, right? So that is part A of the question. Now let's move on to part B, trying to find derivative of f dash x at 3 points. Now for that, first let's define our function now, right? Let's write down the basic definition of our function. So we have f of x as equals to, now absolute value. So absolute value is always split, and this time actually I should have, okay, let me draw like this. Okay, so we'll have 2 groups. I wanted to make 3 actually. Anyway, we'll have 3. Okay. Now 3 means, like, we will see it into 3 parts. Look at it like this. Part 1 of the function, part 2 is the middle portion, and part 3 is the later half after 1, correct? Now if you see, this function is same as the original function x squared minus 1, these 2, right? So we can write this as x squared minus 1. We say if x value is less than 1, right? So that means minus 1 is greater, right? Let's include this equal to also on this side. Okay. Similarly, we have something here which we'll also write x squared minus 1 if x is greater than equal to 1. Right? Let's include these points, corners, with those limits, right? So we are left with the middle part. In the middle part, actually we flipped it over x-axis, right? So y values were made negative, right? So basically it is negative of x squared minus 1 if x is between minus 1 and plus 1. Do you understand? So it's a three-part function basically. Now when we are trying to find the derivative of this function, then we have derivative in all the three portions separately, since these are different equations, right? Now as you will note, first point is minus 2. So minus 2 falls where? Minus 2 is somewhere here, right? So we'll say minus 2, we'll use this equation. The second one is 0, which is here. So we'll use this equation for 0. And the third one is plus 3, so we'll use 3 here, right? So we have to differentiate all the things, correct? So what I will do is I'll just differentiate all the three things in different portions and write f dash x now. So I have f dash x, and let me write like this. Derivative of this is 2x. Derivative of this is minus 2x, correct? And derivative of this is 2x. Now these are the derivatives for if x is less than or equals to minus 1, and this is if it is between minus 1 and plus 1, and this is if x is greater than or equal to 1, correct? Now its values at these points could be written as, so I'll write them right here in between, right? So f dash of minus 2, we'll use this one since that is the region, right? So we can have here as f dash of minus 2. So we'll plug in minus 2 here. So when you plug in minus 2 here, what do you get? Minus 2 times 2 equals to 4, correct? Now if you plug in 0 in the second one, because 0 is in between minus 1 and plus 1, so we get f dash of 0 equals to 0, right? Now if you do it here, so what do you get? 2x, and if you want to plug in 3 will be in this region, so slope of the function at 3 will be equals to 6 plus. So that's what you get, right? Now we did some calculation mistake. This is minus, so this should be minus 4, right? Yeah, minus 2 times this is minus 4. So that is perfect. Now obviously on this point you see it's a negative slope, so it has to be negative. This is center, slope is 0. Do you see that? And here the slope is positive. Do you get it? So that is the slope at all the three different points. So it is negative. So the slope is undefined here. Okay, so we'll kind of extend this question a bit more. I can give you that as an exercise now because I've done the complete work here, right? So what your question now is, this point, these are now here is a question for you. The question for you is sketch graph of f dash x. That is what you need to sketch and then see whether our results are perfectly fine or not. So that is a part which I expect you to do, right? You know how to do it now. Try to do it and then look into my suggestion. So you can pause for another minute, okay? Now here is my suggestion. How will you do sketch of this? For f dash x, we already have our equations, right? So in this region, the equation is 2x. So it will be a positive line, but x values are negative, right? So if you plug in any x points here, it will actually be falling down, right? And at minus 1, what is going to be its value? At minus 1, it is supposed to be minus 2. Let's assume this is minus 2 for us. Let's say this is minus 2 for us, okay? And let's assume this is plus 2 for us. And this is the graph of f dash x, okay? The value. Now, at x equals to minus 1, the value should have been minus 2. but it is undefined. So here you have to draw a hole. That is very critical. And similarly on this side, when you plug in 1 here, right? When you plug in 1 here, you get plus 2. So there will be a hole here. Do you see that? A hole here, right? And as you plug in more values like 2, 4, 6, you get a line, right? So that line is with a slope of 2, correct? So at 1, it is supposed to be 2, and thereafter, it has a slope of 2. So it will be a line like this, correct? Now on this side, when you plug in points like minus 2 and all, so you get minus 4. So it's a line going downwards, more and more negative, right? So it will be a line like this, with a slope of minus 2, okay? Now, how about in between? In between, the slope is at 0, it is 0. You see, at 0, it is 0. But if I have a value minus 1, if I plug in minus 1, so it approaches a value which is 2, right? At minus 1. So it approaches, but it is never there. It approaches a value 2, correct? Similarly, if I put 1 here, it approaches minus 2. Do you see that? But it will never be there. So the graph will be at 0, it is 0, joining these two lines. So this is my function f dash x. I hope you like this kind of thing, right? I purposely made this more slanting because I wanted it to be in the page. Okay, but when you do it on a graph paper, you realize that it has symmetric, right? Do you see? It is symmetric, right? So this will be symmetric. And can you tell me what kind of symmetry it is? So you'll find odd symmetry for this, right? So it is odd symmetric function. Now, have a good look at this question. It is an extremely important question to do. And do a similar problem by changing now the question from x squared to x cube. So make it x cube minus 1 and see how the graph should look like. Okay, thank you and all the best.